Hello! Welcome to the most impactful BigQuery optimization video you'll watch today. I'm going to show you 3 hidden tricks that 90% of data engineers miss. These aren't about writing smarter SQL or optimizing query performance. They're about architecture defaults that quietly drain your budget month after month. By the end, you'll know exactly how to cut your BigQuery costs by 50 to 80% without changing a single query. Let's dive in. First, let me explain why BigQuery costs spiral. BigQuery is incredibly powerful, but here's the problem. The default configuration assumes unlimited budget. You're paying for storage you don't need. You're computing at times you don't need. And you're importing data you could query directly. The good news? You don't need to change a single line of SQL. The fixes are at the architecture level: governance, defaults, and smart infrastructure design. Most teams focus on query optimization, and that's good, but 40% of your BigQuery spend actually comes from the storage layer, not queries, and that's where we optimize today. Let me show you where the money actually goes in a typical BigQuery architecture. Data flows in. That's your ingestion layer. You pay once for importing, batch, or streaming. No problem there. Then it sits in storage, and this is where costs leak. BigQuery stores your data and keeps multiple versions by default. GCS stores logs and backups. This cost is recurring every single month, and most teams forget to optimize it. Finally, you query the data. BI dashboards, machine learning models, analytics all scan your data, and you pay per byte scanned. Here's the critical insight. Storage is 40% of your total BigQuery spend, but teams only optimize the last step, queries. We're going to fix steps 1 and 2. That's where the real savings are. Here's trick 1. Time travel window jail. By default, BigQuery keeps 7 days of time travel history. Every version of every row is stored. If you delete data by mistake, you can undo it. That's nice. I like having an undo button. But here's the trap. Most teams never use time travel beyond 24 hours, yet you're paying for 7 days of storage every single month, forever. The fix is simple. Change the window from 7 days to 1 day. One line of SQL. Alter table, set time travel window duration to 1 day. What happens? You keep the safety net, but you cut logical storage by 85%. On a typical table, that's $2,000 per month saved. Multiply that across your organization, and we're talking millions. 5 minutes of work, immediate savings. Let me give you concrete numbers. 1 table, 1 terabyte of data. At 7 days, you're paying $24,000 per year. Apply the 1-day fix, same data, same queries. Now you're paying $3,600 per year. That's $20,400 saved on 1 table. At scale, that becomes $2 million per year. And this is just trick 1. Now trick 2. Multi-view refresh misalignment. Materialized views are great. They make dashboards fast, but they refresh hourly by default. Hourly. That's 24 refreshes per day. Does your dashboard really need that? The fix is simple. Align refresh to business needs. Daily, weekly. One team reduced cost from $4,000 to $150. That's not a typo. Trick 3 is my favorite. Wildcard tables and federation. Most teams copy data into BigQuery. Copying costs money. But what if you didn't copy at all? BigQuery can query GCS directly. 0 ingestion cost, 0 data movement. For 10 terabytes per month, that's $60,000 per year saved. Perfect for logs, events, and machine learning features. Now let's bring everything together. 1 architecture, 3 optimizations, smart storage, aligned compute, no waste. The result is same insights, same dashboards, same models, but 50 to 80% lower cost. That's hundreds of thousands of dollars back in your budget. Here's your action plan. Week 1, reduce time travel window. Week 2, fix materialized view refresh. Week 3, use federation for logs. 3 weeks, 3 changes. massive savings. You now know the 3 hidden tricks that cut BigQuery costs in half. Subscribe for more real-world GCP architecture guidance. Drop a comment. Which trick are you trying first? Thanks for watching. Let's optimize.